Hi everyone, this is Mr. Richmond, and for this video we're going to be looking at your geology notes, your PowerPoint presentation, specifically Alfred Wegner and his contributions to the continental drift theory. So, Alfred Wegner was a German meteorologist as well as a paleoclimatologist. This word is just a fancy word for the fact that he studied climates of previous years throughout history, and he made some interesting observations as well as collected a lot of data to support his continental drift theory. The first of which is an observation that a lot of you probably made when you were in second or third grade. And you probably thought to yourself, hey, it looks like these coastlines fit together at one point. They look like they fit together like pieces of a puzzle. And that was really his first observation, but unfortunately that's not enough to get your idea or your theory accepted by the scientific community. You need to back that up with some kind of data or facts. So he did a little bit of traveling, and he was finding that these rock layers or these geologic formation, the types of rocks, were similar on each of the coastlines of nearby continents. So we have an example of that right here in Connecticut. If you go down to UConn's campus on Avery Point in Groton, you can stand on rocks that are exactly the same as rocks that can be found on the west coast of Africa. And we can see different types of examples similar to that on the east coast of South America as well as the west coast of Africa as well as Europe and Africa. So that was one piece of evidence that he found. He also found some different fossils that existed on different continents. So he was finding the same types of land animals that would exist on both Africa and South America. And these land animals clearly could not swim across what we know today as the Atlantic Ocean. So this, again, another piece of evidence to suggest that there was kind of a land bridge going on here, that Africa and South America did indeed connect at one point. I think my favorite piece of evidence that he came up with is he was finding these types of ferns, these vegetations in Antarctica that can only exist in tropical climates. So that would suggest that Antarctica was probably at one point much closer to the equator and had a much warmer climate early on, millions of years ago. So he's finding vegetation in Antarctica, or fossil evidence of this vegetation that would not exist in Antarctica today. So pretty interesting stuff, and there's some other images of the types of species that he was finding. So his theory was not accepted by the scientific community, unfortunately, until after his death, because he could not answer the one question that was posed to him, which was, what is making these continents move? He never really had an answer to that. So we have this gentleman by the name of Harry Hess, and during World War II, he was using echo sound, or these echo pings, that would send a signal down to the ocean floor and back up to the ship that he was on. So he was mapping out the ocean floor by doing this. By sending a signal down, you can see different peaks and valleys, and he was noticing that there was this mountain chain in the middle of the ocean. So the results of his work, which we'll talk about in a little bit of how that map was created, was the Mid-Atlantic Ridge, which we have a bunch of volcanoes and mountains in the middle of our ocean floor. If you want to know more about that, you can watch my plate tectonics activity where I show you some examples of some seafloor spreading that's going on. So I would be remiss and would not be giving it credit without mentioning Mary Tharp, who really did a great job and should get most, if not all, of the credit for mapping out the first images of the seafloor as well as the mid-oceanic ridge. This was a time where females were not really accepted into the scientific community. She had a colleague by the name of Bruce Heason that dismissed a lot of her work as girl talk, but she kept plugging away, and she did a great job of mapping our first image of the seafloor, which we know kind of looks like this. So we have these mid-oceanic ridges existing in the middle of our ocean. These are going to be divergent boundaries. Again, watch my plate tectonics activity, and you should know that a divergent boundary means that the two oceanic crusts are pulling apart from one another. And when that is happening, we have new land that's forming in the middle of our ocean, pushing away that older land towards the coastline. So that's an important concept for you to know regarding seafloor spreading. I like this image here. And if I went to full zoom, I believe you would see the actual movement of the land. So you should know from this simulation, or this image, that new land or magma is coming up, seeping up inside the Earth's surface, cooling, hardening, creating new land along the mid-oceanic ridge. So we have younger land towards the ridge as well as older land being pushed away. So this is really the missing piece of evidence that Alfred Wegner did not have, unfortunately, before his death. And he really did not have this to help support his continental drift theory, because this is what is really the driving force of moving those continents. So unfortunately for him, this was data that was not accessible. So I hope this moving image allows you to really visualize what's happening here. We have magma coming up from inside the Earth's surface, cooling, hardening, and pushing away older land more towards the coastlines of other continents. And the last thing that I want to leave you with, which I talk about later in the PowerPoint presentation, is the layers of the Earth and how they are made, or the composition of the types of layers, really allows the continental plate to move. So what I mean by that is you have the lithosphere, which is more of a solid that sits on top of a liquid, or more of a liquid form in the asthenosphere, and this provides or acts like a lubricant, which allows for that lithosphere to actually move. So this is the driving force of the continental drift, and this really supports why we accept the continental drift theory today. And this is the main piece of evidence that unfortunately Alfred Wegner did not have prior to his death. The remaining PowerPoint slides, I talk about transform, convergent, and divergent boundaries, and I have some images, some good images for those. I would also encourage you to go ahead and watch my FET plate tectonics activity that goes along nicely with those images. As always, if you have any questions on this content, please do not hesitate to contact me. I hope this helps your understanding of continental drift theory, and good luck with your future assignments.